Welcome to the second tutorial in the series about creating a tile map from scratch in Swift and Sprite Kit. I'm literally going to code this from scratch so we can do this together and you can see exactly how it all goes together. Couple of things I'm going to assume before we start. One, you're not a complete novice at Swift and Sprite Kit, so you understand what's going on. Like with most things, like obviously I'll explain the code that's creating the tile map, but I don't want to have to explain functions, certain variables, arrays, etc, etc. You should already know what that stuff is. Secondly, you understand what a tile map is, all the basics of a tile map and its functionality within a game. I will go into some detail, but I don't want to go into massive amount of details. So, before we start, you should have the blank project set up like we did in the last tutorial. If you haven't, I suggest you go and look at it. You can either find it on this YouTube channel, I'm uploading it now, or you can go to my website, tilemap.com, and it might not be the newest post, but it will be somewhere there. Tutorial is the start one. There's the video that I'm uploading. Open the tutorial up. So my internet is really slow. Yeah, and then here's the code. So if you just, it's only a short tutorial, it's literally a couple of paragraphs and a bit of code. So it shouldn't take you too long to get caught up. Right, anyway. So if you remember from last time, we run the project, we literally just have a blank project and a blank scene, so our starting point. So before we get anywhere, let's create a new file for the tile map. We'll just call it tile map. It's a Swift file. So I hate it where it puts it down the bottom. Instead of foundation, we support Sprite Kit, and we're going to have to create a few classes. Now obviously we're going to need a tile map class, which is the object we're going to create when we want a new tile map. We're going to need a tile set class, which is going to be the thing that holds all our different types of tiles and various tile data, shared tile data, for instance, each tile size, or maybe an offset and stuff like that. Obviously I'll go into more details as we flesh these classes out. We're also going to need a tile data class. Now, tile data is not what gets drawn to the screen, it's actually what the tile set stores. Like tile data, for instance, if a tile set holds loads of tile data, each individual tile data will let each tile know like what image it is, any properties it has, like so if we're pathfinding, how it reacts to certain physics maybe in the game, because we don't want to store them in individual tiles. Literally the individual tile class which we're going to create, which these are the things that actually get drawn to the screen. We want to keep this as simple as possible because there could be thousands of these, and we don't need every tile to know that it's collidable or not. We can just point to the actual tile data. You noticed I've made it an SK node class, and that's because we will eventually be adding these to the node tree. While we're at it, we might as well make our tile map an SK node class as well, because we're going to add the actual tile map to the node tree so we can see it within our scene. So let's get a few, well, let's tidy our code up. Let's keep it neat so we know what we're doing. So I've got that OCD when it comes to my coding, so I'm keeping it clear. Obviously I am just self-taught, so So you might see dodgy things that I'm doing, and if you do, please just leave a comment and let me know I can do it better, because I'm always up for improving. Alright, and if you don't know what these marks are, they're actually pretty handy. If you go up here, as this file gets bigger and bigger and you don't want to scroll through stuff, you can quickly just click on something and it'll highlight it or scroll to it within the file. So let's start with our tile map, our basic tile map. We're going to need to set a few things. We're going to need a map size, which is obviously it's going to be a CG size. Or, well, even before that, we're going to need a name for the tile map. You notice I'm creating these all as lets constants. That's because I don't want to create an tile map object and then worry about loading a different map within that same object. I don't see the point of that with something like this. If you're going to create a tile map and then you don't want that tile map, you can just unload it and then create a new object. We're also going to need, say, a maximum map size. This is going to be used for our array later, so we know exactly how big it can be, and it's always going to be the maximum size. We might not necessarily have to go through it because of the map size, but the max map size will be that. And you notice I've made it an int, not a CG size. That's because I'm not going to have a different width and height. They're going to be the same. We're going to need obviously a tile set, which will have all our different tile data, and we're going to need an array of tiles. So it's going to be a two-dimensional array of optional tiles. Oops. So another thing I want to focus on, because I don't see the point of doing it or teaching you guys wrong, or just for the sake of doing it quick. I'm going to do most things data driven, so I'm not hard coding it. I'm not going to hard code the name, I'm not going to hard code this, everything's going to be data driven. So when we actually come to writing the initializer, sorry, once I'm drinking. The base initializer is actually going to be able to set all of these things. So, and when we come to loading from data or a tiled tile map file, which we'll later in the tutorial we're going to do, we're going to be able to pass our own tiled tile maps. We'll use them as convenience initializers, and then we're going to have to call this one eventually. So nice, right? Initializer. Tile set. We're actually going to have to pass our tile set object in, so it'll have to be created from somewhere else. And let's just set all those. And of course, because we're in SK node, we've got to call super.init before we can start editing our things. What is this error here? Oh, so we don't, because I'm taking this from node, we don't have to add our own name prop either. And because it is an SK node, we might end up implementing this in the tutorial so we can save. But actually, I'm going to say we are going to end up implementing this. So then we can actually save. We might edit the map in the game and then save it, or a certain map state, and we'll be able to save it and load it. But this is for later. Okay, we can't set the name before we've called super, because that's part of the super class SK node. Another thing we're going to have to do is fill this array up. So while we're doing that, we're going to go, and the way we're going to access the array is similar to as you would in C or C++ or any other language. it's going to be something like that. So that's going to, X and Y is going to be our tile. So the way we do that, for X from 0 to our max map size minus 1. So basically we're going to loop through the array, and now we're given our, well, basically just formatting the array basically. So we create another, this is the second part of the array, the Y coordinate, or the row if you can, count, and the count's going to be max. In which case that's max map size, and we're just going to nullify that out. So we got our basic map set up there, and we can create that in the scene, and obviously nothing will happen because we haven't actually got anything to put there. So next thing we're going to want to do is try and flesh out this tile set. So every tile set needs, it's going to need a name as well. So in case we're saving it or loading it from a file, we need a name for that. We're going to need a tile size. So every tile in a tile map generally, or I'd say near enough 100% of the time, you won't have different size tiles like for the actual base map. So here we can set a different tile size, and we're going to need an array of tile data. We'll just do it this way. So there's two different ways of making an array there. Let's create the initializer for that. Tile size. God, I can't type. You notice we're not actually loading any tile data yet. How are we going to do that? Well, let's create the tile data first. What's the problem here? Oh, sorry, I've written that wrong. For X, there we go. Right, so that's sorted. Okay, so basic tile set up. Let's do tile data. Now, basically tile data can be whatever you want it to be, but there's going to be some core things we're going to need to know. So every tile obviously needs a graphical representation, and in Sprite Kit that's going to be a texture. So we're going to go texture, sk texture. Actually, we're going to make that letter. So we need a texture. It's guaranteed to be a texture. Tile data should also probably have a name, so we can identify it. You could give this be an integer and a unique number or something like that, which I guess when we do come to pass it, or pass a tile map, we're actually going to need an ID number for it. But for now, we're just going to use name because we're going to create it without tiled. What else could we use for tile data? Yeah, I think that's it. We'll go with that. We'll go with that for now. We're not going to overcomplicate it. We're going to try and get it up and running as quick as possible. We're going to need a texture. And we can pass that as a string. Just because we come over here. So self.name equals name, self.texture equals sk texture, and we're just going to go image named. It's going to be texture. So that's our tile data, and our tile is actually, so our tile is the actual class that's literally going to be drawn to the screen. So we want to keep it as small as possible, but we do still want to be able to access our data, so we're going to need, that's what I forgot from tile data. Tile data should know what tile set it's from, so that tile set. And we're actually going to put that in here as well. Alright, so tile is going to need a sprite. This is what the graphic we're going to draw to the screen, and it's just going to need some data. So we'll pass it a texture and the data that it's going to use. Or, well, actually we only need to pass the data, because the data is actually going, if you remember, it's going to tell us what the texture is. This is an SK node, so we've got to call super.nn. Oops. Sometimes Xcode really does take a piss. Alright. So we go self, let's call self here sprite, equals SK sprite node. With the texture, we do data dot texture. And because it's a node, it needs to be able to load. We do that. We can do self.data. Just for the sake of it, we're going to put self here just to keep it all nice. So we got our basic setup. Obviously this by itself is not going to draw a tile map, but these are our basic classes that we're going to use to do that. Right, so before we carry on, we're going to have to create some tiles. So open your favourite tiled paint program, which is a basic 32 by 32, and let's create a few tiles. I'm not going to bother doing any detailed ones. Just do a green one for grass. Maybe that'll do, green. I'm going to save them. Let's create a new folder within our project. Let's call it, we're going to make it an atlas as well, so we'll just call it tiles.atlas, and we'll save this as grass. Make sure it's something Sprite can read, and we should have something else. So let's create a water one as well, just because it's nice to see that we've got different, at least a couple. We'll do a third one as well, just for the sake of it. Why not? It's a laugh. There we go. It's going to be our dirt. Obviously, your art skills might be better than mine, so you can spend as much time as you want in tiles. But for the purpose of this, I want to get it doing as quickly as possible. Right, so now we've got our atlas, tile atlas, added to the project. Alright, so how are we going to go about creating them? I think before we begin doing that, let's just make sure this works. Let tile map equal tile map. Let's call it test map, map size. And we'll just do a small one just for testing. Maximum map size can be 32 by 32, and a tile set, we're going to have to create a tile set to pass in here. So let tile set equal, we're going to call this, we'll just call it tile set, and the tile size, what do we say, 32 by 32. So, like I said, we could have hard coded all of this information, but I don't want to. But I still want to be able to create it pragmatically if I have to. Like, obviously, our tile set hasn't actually got any tiles in it at the moment, and there's no way for it to be able to read any other data because we literally just got images on it. So that's all working. So let's just create a function for the tile set. Let's call it add tile data. And if we look at our tile data, what do we need? A name, a texture, a name and a texture. So we're going to call it a name, string, and a texture. Because of the way we've got this working, we can use the same thing. So we'll just do add tile data name. And this is going to create new tile data. So let data equals tile data name, and if you remember the texture's a string as well, it's going to be the same as the name. That's how we're going to do it. And the tile set's going to be self, and then we're just going to do tile data. I wish it would stop doing this. Tile data, and we're going to add that to the array of our tile data. So there's a quick way of adding new data. If we look at the names, we just want to use dirt, grass and water, and we're going to go to our scene and add them now. So tile set dot add tile data, I'm going to call it grass, water, and dirt. Let's just make sure, yeah, there's no errors there. You know if it didn't work when it comes to, where's tile data? Here. If we typed one of them in wrong, let's just prove that point. If we type that in, it should have come up. It couldn't, or not. Okay, it didn't come up. Okay, I am completely wrong. Should have said it couldn't load this image, but never mind. Right, so now we got our tile set up with our 3 different tiles in. They've all got tile data. There's no actual different data yet, and we've got our tiles. So let's get to the map and actually create the tile map. Let's create a new function. Create blank map. So now, so obviously we need to scroll or loop through every possible tile. Now we are creating an orthogonal map. I know the video I posted before was an isometric map, but we're going to add that later. I just want to keep it quite basic for now. What's the problem here? So we've got to cast, because this is a CG size, there's always a CG float. We'll cast them to ints. That should keep that happy. Alright, so now for every tile in our map, we're going to have to, sorry, for every space in our array, it's going to represent a tile. So hold on, that's another actual thing a tile needs to know. A tile needs a coordinate. And we're going to do CG point. And we should actually set that here. So, tile has a coordinate. And our coordinate is actually going to be the same as the position within the array. So 0, 0 is going to be the top left of our map, and the maximum map size and width size is going to be the bottom right, -1, etc, etc. So let's create that. Yeah, well, let's create the coordinate first. So that's just going to be whatever x and y are. And then we're going to create the tile. And the tile is going to be coord. And we needed data, didn't we? So we're actually going to have to create the data before we do this as well. So let data equal well, this is the point. I shouldn't create data here. The data we're using for each tile is going to be from our Tilemap tile set. Now there's a possible three different data, but for now we're just going to grab the grass data. So we know it's actually going to be an optional. So if let data equals tile set tile data, maybe we should have created that as a dictionary. Yeah, we'll make this a dictionary, so it makes more sense when we're actually grabbing the data. And when we do that, there. So now we can easily do tile data, and we're just gonna use all grass tiles at first. So let's move all that forward. And before we do that, we're actually going to create another tile layer. We're going to create another node that we're going to add to this tile map. The reason I do it this way is because if you think of how Sprite Kit works and with its anchor points, when we add a tile to the tile map, when we're positioning the tile map and we're scrolling it around the screen, which we will eventually do, each tile is going to start, and let me run this. At the moment we've added our tile map to the screen, and our tile map is actually positioned here at 0, 0. Now obviously we could position it wherever we want, but when we start scrolling through the map and when we're creating a map, the tiles are going to, like the first tile, because its anchor point centered in the middle, it's going to be there. And then we're going to go wherever the width is, and the next one down, it's going to start creating it off of here. And it's going to be off screen, which is not a problem because we can always position the tile map. But to save messing around with offsetting the first tile position, so we're actually creating it in the positive y and x, I'll just create another layer and then I can offset that layer rather than the tile map or the tile itself within the tile map. So we're going to add all these tiles to the tile layer, and then when we're finished we're going to position the tile layer so the bottom tile's going to be on screen, as you will see. So we do add child tile. At the end of this, well, we don't even have to do that in the initialization. We can actually do that here. Tile map dot create blank map. And nothing's being seen. Let's just position this tile map. Let's just have a look what's going on. Let's just get a random position and see if anything's getting drawn to the screen, which it's not. And if we have a look back, that's probably because even though we're creating our sprite, we're not actually adding the sprite, which is a bit stupid. Alright, so add child sprite. Now you'll notice we've got one tile drawn, and the reason for that is because we're never actually setting a position. Now, because this is an orthogonal map, we can actually work out the position pretty easily. It's going to be the tile size times our coordinate. Now, we could put that in here, but we might as well just create another function. And I'm going to call it the function tile position for coord. We're going to pass in the coordinate, and it's going to give us a position for that tile. So, like I said, we have to think about how we're going to go through this. So it's hard to explain without a grid or something. Right, let's open tiled. Let's open tiled. Let's create a new map. Bloody blah. If you haven't used tile before, you should probably have a look at it, because you could create your own editor, but there's literally no point. This basically does it all. Let's just add our 3 tiles. God knows what size I've made these. Hold on a minute. Where's map properties? Okay. View grid. So this is our tile map. We have to decide for our positions how it's going to get drawn. So we ideally, if you look down, here's the coordinates of the map you'll see when I hover over. So here's 0, 0. And if you know Sprite Kit, then you know the Y is actually reversed, which doesn't really help matters, to be honest. But that's how it is. So we have to deal with that. So we're going to draw each tile from 0, 0. We're always going to start at 0, 0. We're going to draw like that, then down, then down, then down, then down, and down. Bloody blah. So I hope I'm making sense, because I don't think I'm very good at this. But right, so working out the x position's easy. So we just go x equals tileset dot tile size dot width times code dot x. And the y position, remember the y is reversed, so we do tileset times code dot y. But yeah, that will create a reverse map, because as the coordinate increases, it will create, say this is the edge of the screen, it's going to create the first one here, and as it increases it's going to create it upwards. And you'll see if we could load this map, that this tile will be here and this tile will be here, so it'll be like a mirrored Y, which is not what we want. So we want to times, if we just put minus there, or on the other one, it should work. We'll just return CG point X. Now and we'll set tile position equals tile position of code, and we'll pass in the coordinate. Now hopefully when we run this, we should have, yeah. Now, obviously we haven't got no way of checking if this is 0, 0 or not. This should be 0, 0. And obviously down here somewhere should be our maximum 8 by 8, or 7 by 7. Sorry, because we're starting at 0. So let's create. See, this is okay, but like I said, I didn't want to hard code anything like this. So really what we want is to either pass a lot of data, map data in, and then literally read that data, or we can just pick a random tile. So let's create a quick random function where we can ask the tile set to give us a random bit of tile data. So we're going to go random tile data. It's going to return an optional tile data. It's going to return an optional just in case there is no tile data. So if there is none, we can quickly do that now. We can check that. If tile data dot is empty, return nil. Now we know after that we're definitely going to return some tile data, even if there's only one in there. It's not very random, but that's all there is. So. Right. I have actually got a handy random function that I think I got off here. Random int, we'll use this. We'll just make it a global function for now. Mark global function, we'll copy that. I got this off Stack Exchange or something like that. Literally, well, it wasn't as I've edited it a lot. It was an extension to the range type in Swift, and I just made it a function because I don't know, it just seemed weird writing a random range and then putting a function afterwards. So yeah, it basically takes a minimum and a maximum, and it's going to return you an integer. So if we get our random index, we'll call it random index equals random int, and our minimum is going to be 0, and our maximum, because we've actually changed this to a dictionary now, we need to find out the amount of dictionary entries total. So we do tile data.keys.array.count. I think that's going to be, no, it works, and I believe that actually has to be -1 as well. So that gives us a random index within a dictionary, and then we just need to return that random index. So that can be return tile data, and the index, we're still going to need the string value or the key value for the index, so we're going to have to do tile data, keys.array, and then we're just going to access the keys array via the random index we just got, and that's that. Right, so now you don't have to set this, we just go tile set random tile data. Okay, sorry. With this random integer, it's already going to give you don't need to do -1 for an array. So if I run that again, we should have the dirt included there as well. Alright, okay, so we're getting somewhere now. We're just creating a blank map with random tile data from the tile set. I think it might be a good time just to actually quickly look at what's going on as well, just so we can reflect. So we got our tileset object here, we're going to create it, bang, called tileset, tile size. There's no tile data, and as you see, as we go through, we're adding 3 different tile data. So this is the index I was talking about within the dictionary. And obviously the tile data now is added. We create the tile map, set in the tile set there, and then we set the position. Okay, so we know everything's working, get rid of that breakpoint. It's always good to check that everything's working how you think it should work. Now, it really would be nice if we could check, if we could actually click on the tiles and maybe change them to another random tile data, just to check what's going on. So if we go here, and we actually use our touches began, we use that. Quick way to get a touch from here in touches, and then we need to work out the location equals touch.location in node. Now we can either do this one or 2 ways. We can pass the scene location to the tile map and let it convert it to the tile map, or we can just convert it here, and it doesn't really matter. But I think in reality it's easier to convert it here, so we're going to have to create a variable in the class. Tile map equals tile map. So here we just do that instead. So not equals, and we're going to put an exclamation mark there. Right, so now we've got a tile map. And now we're going to need a function in the tile map to actually convert this location and get the correct, pick out the correct tile and then change it. So let's do tile. We'll get the coordinate of it first. Tile code for position. And we're going to call it tile map position, so we know the position we're passing into the function actually has to be into the tile map node space. And no, we're just going to return the tile coordinate. So basically, to get this, we just need to do the opposite of this. So let's think. Let's just write that x equals x. Alright, so again, because I've added a tile layer, we're actually still going to have to convert this position to the tile layer position. So we do let, can actually change this to a var, to be honest. Tile map position equals convert point tile map position tile map. Problem. Sorry, it's called tile layer. Yeah, so we know this is getting passed in within tile map node space. We then have to convert it to where our actual tiles are. We might have to adjust this. Well, let's see if we're going to get back the correct coordinate first. So we're going to do position.x divided by tileset.tile size.width position.y. Now we should really reverse that. Let's just see what kind of results we get. Well, we're not going to get anything because we haven't even asked. Alright, if let code equals tile map dot tile code for position and pass in the position, and let's just print that code, see. Okay, it's not even an optional. Sorry, I'm very tired and wow. Well, that's not working, is it? Something's very, very wrong. And that is because I'm an idiot, and the position I'm using is actually the tile map's position. Let's use the actual position that's passed into the function now and see if that changes anything. 5, 6, 7. Yeah. And we should probably convert these to integers for a start, because we don't. It could be useful to know how far in the tile we are. Yeah, but that's, you can see that's 7, 0. And we don't want the y to be minus, so what we're going to do is divide that by, oh wait, I just think I've messed that up. Four, 5, 0, 1, 2, 3, 4, 5. Oops. So yeah, I know that what the problem is here. The problem is if you remember what I said about anchor points, and that like this is 0, 0. This is 0, 0 tile, and it goes off a little bit here, and our tile is actually centered. And generally, when you make a tile, you don't want that behavior. We should either make the anchor point here or here, and because of the way we've done it, we should probably make it the top left corner, to be honest. It could be the bottom left, but then we have to remember to minus the tile. Let's just make it the top left. So when we go to when we create a tile, we're going to do anchor point. So we have to set sprite anchor point. So 0, 1. That's the top left of the sprite. So let's just make sure I've got 0, and then that's roughly the still 0, 0. We move into 1, 2, 3, 4, 5, 6, 7. It should be 7 all the way. Yeah, so I'm not going to well, we should convert this to an integer, because if we try to get this, use this coordinate to grab a tile, then it's going to be strange, but it could be useful to know how far across the tile you are. Like, just bear that in mind. If you ever need that information, you can do it. But for now, we're going to just convert these to integers. We'll just do it here. And let's just make sure they're getting converted, right? Yeah, so 0, 1, 2. So this is the behaviour we're expecting now. We're getting the correct coordinates. And what did I say we was going to do? We was going to set a random. New data from the tile set for that tile. So we need a way to get the tile. Now we can do this tile for code. Now we're going to pass for a code. This is where I said it's important to have an integer representation rather than one with floats. And we're going to maybe return a tile depending if the coordinates work. Now the reason I did a two-dimensional array is because we can actually return a tile at a location in the array really easily. We don't have to search the whole array and search for a tile with this specific coordinate. But we can do, but we don't have to. A quicker way would just literally be to access the array with its coordinates. So let's do that now. And this is where the max map size comes in. This is where I'm going to ensure that I don't go outside of the array size. So let's just create another quick function just to check if the coordinate's valid or not. So valid code, and it's going to return a boolean. So well, actually we'll just return true. We'll check against if it's false. So if code.x is less than 0, or code.x is greater than max map size dot -1, or code.y. So hopefully this should be pretty self-explanatory what I'm doing here. So or not. I think that's because I've got well, actually they need to be converted to CG files. Alright, happy days. It's just this is a problem of working with CG points, but it's just like you could create a tuple instead of using CG size, and it would be a lot easier to code yourself. But when you're working with Sprite Kit, everything needs CG points, and it's just I think it's just easier to work with the framework you've got. Just follow their standards. Alright, anyway, so the first thing we're going to do is we're going to check to see if this code's valid and it's not going to cause a crash. So if that's true, otherwise here we're going to return nil, guaranteed. So if our coordinate's valid, we can then access the array directly. So we can just return tiles. We're going to have to cast this as well. Code.x. Come on. And there we go. We could go one step further here, and if there's not a tile at this particular array location, it doesn't mean that there's not a tile. Well, it should mean 99.9% of the time it should mean that there isn't a tile with the same coordinate, because if it's not at this location, God knows why it's at another location. But theoretically, it could be if you messed about with the tile somehow and moved a tile and didn't change its coordinate. But this should work. So now we can go back to our scene and do some cool things. So we've got the coordinate. We get the coordinate, and then we go if tile would ask our Tilemap for the tile for our coordinate. If the tile's valid, if we know we've got a tile. This is one of the great things I do love about Swift. I do like the optional checking. Sometimes it can be a pain in the ass for certain things, but I do like the way that, especially here when I'm asking that I need a tile set and I'm guaranteeing Tilemap I'm passing it a tile set. I'm not passing it a pointer. I'm actually going to give it a tile set object. That's 100%. I like that about it. Alright, but anyway, now we've got our tile, we can do whatever we want with it. So let's just set our tile alpha to 0.4 or something like that, just to see what we do it. And it's not going to work for some reason. And why would that be? So this is another thing like you should always do. Always check using the debugger what's going on. So let's go into here, because I'll probably mess this up somehow. X is 4, Y is 1. And you can check the max map size 32, so this shouldn't fail. It returns true. So let's have a look in our tiles array. And okay, so we've got one vital step. At the moment, this array doesn't even contain any tiles. Even though we're looping through here, we're not actually adding any tiles to this array, which is pretty stupid, because we have no references to them other than that they're children of this tile layer, which is why they're still stored and shown on screen. So here we have to do tiles x, y equals tile. Right. So now we're setting our array. This is why I like using a two-dimensional array, because of this syntax here. It looks good and you can see exactly what you're trying to do. So now we should be working. So now when I click here, So look, yeah, that alpha's getting set, so carry on. So you can see there I'm setting the alpha of each tile I'm clicking, and it's all working. Right, this is good news. Right, we're getting there. What should we do next? I think that will be enough for today. I think this is probably, I've probably droned on long enough. But I hope it's given you a good insight into, like, from very little code there. And to me, it's not that complicated. Like, you might be looking at it and thinking, whoa, but like, there's nothing here that's super complicated. And I'll be building. If you get to this stage, I'll be building on this in the next tutorial. Like, we'll go into a lot more in depth about making the Tilemap class very safe. So you're not gonna, like this here. I mean, this still can't fail, but it's still a bit stupid because I'm only checking max map size when really I only want to be checking against the map size. There's no need. But this does ensure that I'm never gonna try and access the something outside the array, which can't be nil. Yeah. So a few things we're going to do next time. We're going to make a camera for our scene. So I've got this positioned at 200. This is the point of the tile. I've got this positioned at 200. 200. It's not very good one. We can't actually move it about and have a look around the tile map. I might show you how to do zoom in, pinch zoom. We do give it all that. But for now, I think this is good enough for today. And should give you a good starting point. We're also going to go into more data-driven stuff, so we're not going to create a tile set like this. We're either going to create a property list ourselves, or we're going to look at using a map created in Tiled and start passing that within our project. So anyway, I hope you enjoyed the tutorial, I hope you've learned something, and if you've got any questions or suggestions or anything along those lines, don't hesitate to post a comment, and don't forget to check out my old website. Hopefully this video is probably uploaded by now. Yeah, check out my website, post any comments on there or stuff you like. It will help keep me motivated, keep me posting more tutorials for you guys. So yeah, thank you for watching.